Okay, so first thing I would like to talk about is adding in the horizontal and the vertical form. The horizontal form is good when you have smaller numbers involved, maybe 2-digit numbers, things like that. Okay, so something like this. 25 plus 13 equals 38. Oh, just for some lingo here, some vocabulary. Each of these numbers that we are adding together are called addends. That's an E right there. And the result of doing the addition is called a sum. Okay, now when I'm doing a problem like this, I kind of do it a piece at a time. Right? I would do 25 plus 10, which gives me 35, and then add the 3. Okay, so I'm taking advantage of the properties of the place value system, in that this 1 stands for one group of 10. And I'm throwing that group of 10 onto the 25 first. So 25 plus 10 gives me 35, and then I add the 3. Okay, for another quick example, we could do something like, oh, I don't know, 13 plus 18. Okay, so once again, I'm thinking about my place value properties. 13 plus 10 is 23, and then tack on 8 to the 23, and that gets me up to 31. Okay, so that does involve some carrying there, right, because the digits in the ones place added up to 11. So I can't write 2 tens and then 11 in the ones place. I have to carry over a 1 to the tens place. And that becomes a little bit more evident when we do something in vertical form like this. And of course, vertical form is what we're all pretty familiar with from school. If we did something like 507 plus 394, okay, we add these two, that becomes 11. Now, I can't put an 11 down here in the ones place. That won't work. You can't have 11 in the ones place. We have a base 10 place value system. So the biggest digit you can put in any of the places is a 9. So what I'm going to do is I'm going to put a 1 down here and then carry over the group of 10. Because 7 plus 4 gave me 11. That is 1 unit plus 1 group of 10. So I'm bringing the 10 over here. Okay, now here 1 plus 0 is 1, plus 9 is 10. I'm going to put the 0 down there and then carry over my 1. And that would be 901 for my sum in that problem. And of course, you can do that with any number of addends. We are not restricted to just 2 addends. We could tackle something like 5,576 plus 1,922 plus 649 and do the addition here. Now, this would be very inconvenient to do in the horizontal form. Okay, when the numbers get bigger, the vertical form is the way to go. So let's just crank it out here. 6 plus 2 is 8. Plus 9 gets me to 17. And I carry my 1 up here. 1 plus 7 is 8. That's 10. That's 14. So it's a 4. Carry my 1 again. That's a 6. 15. 21. So I'm going to carry a 2 up here. Okay, notice here, coming from this column to this one, 1 plus 7 was 8, plus the 2 gets me 10, plus the 4 gets me 14. So I put my 4 down there, the 1's digit from my sum of this column, and then I carry over the 1 that was in the tens place, the 1 from the 14. But in this situation, 1 plus 5 is 6, plus 9 is 15, plus 6 more is now 21. So I write down the ones digit here, and I carry over a 2 to the next column, and then over here I have an 8. So my resulting sum is 8,174 in the vertical form. Okay? Now, when you're working out the problems for this section, I would highly recommend writing them out longhand. I want to see your work. I want to see your carrying. Okay? One of the purposes of this class is to help students develop a number sense. In other words, get a feeling for how numbers work. So I want to see this work when you submit your assignment. Okay? Do not just write answers when you submit your assignment. I need to see the thinking that goes into making those answers. Okay, so one other thing I wanted to go over is using the associative and commutative properties of addition. Okay, so you are probably familiar with these. So the commutative property of addition tells us that we can switch the order of things we're adding and get the same result. So for example, 2 plus 5 is the same as 5 plus 2. The associative property applies to grouping. Okay? So if you have, let's say, 3 things being added, well, you can only add 2 numbers at a time. So if I was to do 3 plus 2 plus 7, these parentheses, and I'm sure you remember your order of operations, parentheses indicate what you're supposed to do first. So these parentheses indicate I'm supposed to do the 3 plus 2 first. Well, the associative law assures me that I would get the same answer if I did the 2 plus 7 first and then added the 3. Okay, the associative law can be very handy when you are finding sums. So we'll call this finding sums the easy way. What you want to do is, let's just start in with an example. Let's do something like this. Okay. 13 plus 8 plus 12. Okay? If I add the 13 and the 8, I have to do some carrying. All right? Now, I can make this a much easier problem by doing this. 13 plus 8 plus 12. Now you might say, well, how would I know to switch? Well, the 8 and the 2 are giving me a hint there. I'll write down some lists of numbers that you want to look out for called compatible numbers, but 8 and 2 is one of them. Basically, any pair of numbers that makes a 10 will make your job of adding easier. So we're doing 13 plus 20, which is 33. If I do it this way, I have no carrying. Let's try another one here. 125 plus 75 plus 41. If I were to look at the problem as it stands right now, I'm supposed to add the 75 and the 41 first. That involves carrying to find the result. I know it's going to involve carrying because I'm going to have to add the 7 and the 4, which gives me 11, which means I'm going to have to carry. However, if I look at this and realize that the 125 and the 75 combine together to give me 200, I know that if I add it this way, I can get the sum with no carrying. 125 plus 75 gives me 200, and of course 200 plus 41 is 241. Okay, so if you have longer sums, meaning sums with more numbers involved, you can kind of gain even more benefits. Let's look at something like this, okay? 23 plus 5 plus 7 plus 15 plus 10, okay? So when I'm looking at this, I'm seeing a couple of pairs of compatible numbers. In particular, the 23 and the 7. Anything that makes a multiple of 10 is going to be helpful. Okay, so I'm going to bring this 7 over by the 23 because the commutative and associative properties together basically say I can do this addition problem in any way that I choose. I don't have to do 23 plus 5 and then add the 7 to that. I can take the 7 and add it to the 23 first. Well, the 7 plus 23, of course, is 30. And here, notice 5 and the 15, that makes a 20. And the 7 and the 10, okay, that's just 17. Oh, wait, no, sorry, the 7's already gone. Right, those guys were together over there. These guys were together over here. I'll put some arrows in there to kind of make it clear what my thinking was. And then we got a 10. So add those together, and your resulting sum is 60. Okay, so when you have a bunch of numbers to add up like this, don't just plod straight through left to right. Look at the whole thing and see if there are any compatible numbers. And while we're at it, let me make a list of what those compatible numbers are. As I mentioned, compatible numbers are anything that gives you a multiple of 10. So 1 and 9 are compatible numbers. 2 and 8. 3 and 7. Okay, so right up here, I saw that 23, and I looked further down the sum, and I said, oh, there's a 7. If I combine that 7 with the 23, it gives me a multiple of 10 and makes my adding job easier because there won't be any carrying. 4 and 6. And then, of course, 5 and 5. Anything with a 5, look for another 5. To have a pair of compatible numbers. Okay. Sometimes when we're dealing with a whole bunch of larger numbers and we just need a vague idea, well, not a vague idea, but we don't need the exact answer. We just need an estimate of the answer. Rounding can help us out a lot. So let's do an example just like this to kind of show you how it works. Now the technique that we're going to use in this example is called front end rounding. Okay, so let's say we had to do something like this. We have to add 51,246 plus 578 plus 37 plus 4,599. Okay, so 4 numbers, one of them is really big, a couple of them are kind of big. We could knock it out in column form if we had to do this, but if we just need an estimate, I'll do something like this. I'll say this is a squiggly equal sign, is approximately equal to. Okay, so we'll call this one 50,000. We'll estimate that to be 50,000. We'll call this one 600. We'll call this 40, and we'll call this, oh, you could call it 4,600. Just go ahead and call it 5,000. Okay? And here, the neat thing about this is if I do this adding, it's 55,640, right? Notice I went and added these first. I have 50,000. Over here I have 5,000, so I have 55,000. I have 600 and I have 40, so I have 55,640. Okay, so if I didn't need the exact answer and just needed an idea of how big this sum was, it's about 55,640, or about 56,000 if you want to round this again. Okay. So a couple more things I want to talk about. When we start getting into word problems, there are a few key phrases to look for that will indicate the operation involved should be addition. Okay, so the key words and phrases to look for. Gain. Okay, if there's a gain, we are increasing a quantity. Okay, if, I don't know, a YouTuber gains subscribers, he has added to his total number of subscribers, right? An increase. More than. If you see any of these phrases in a word problem. All together. Combined. Okay, anything like that would indicate we are talking about the operation of addition in our word problem. So, for example, if I was talking about 13,567 more than 18,788, if we're talking about finding a number that is 13,567 more than this other number of 18,788, what number are we talking about? Well, we take these two and we add them. Let's just put them in the vertical form. Okay, this is 15, carry the 1. That is another 15, carry the 1 again. That's 13, carry the 1. That's 12, carry the 1. That's 3. Okay, ton of carrying. Did the whole thing in vertical form. Okay, and what number is 13,567 more than this other number? Well, that number is 32,355. Okay. One quick application where you make use of the operation of addition is when you are finding the perimeter of a figure. And that is a fancy or official way to say the distance around a figure. So if we look at a quick example here, draw myself a little rectangle. Okay, let's imagine that this rectangle is 14 inches by 6 inches. Okay, the perimeter, if I was going to walk all the way around this rectangle, I would need to go 14 inches. Let's say I started here in this lower right hand corner, 14 inches, then up 6 inches. So my total distance traveled is 14 plus 6, plus another 14, plus another 6. Okay, that's 40. Group them like this, right? 20 plus 20. These two together are compatible numbers. That's a 20, that's a 20. Add the two 20s and you get a 40. Okay, so the perimeter of a figure is found by adding up all the side lengths. So that's a little application of the operation of addition. Okay, so that should give us all the tools we need to work on this next assignment.